Chapter 8, Algebraic Techniques, the harder algebra of Year 9 Math. Let's start with expanding binomials first. Well, revising key terminologies of algebra, because we'll need to use them very soon. Okay. So first of all, the letters in an expression that you don't normally see when you're in primary school, we call them pronumerals or variables. They're there to represent any value that we want them to present. Okay? The letters multiplied together, sometimes also multiplied by a number. Anything that's connected by multiplication or division, we call them a term. Different terms are connected either by plus or minus. And different terms connected by plus or minus without the equal sign, we call it an expression, algebraic expression. Okay? Different expressions can be connected by an equal sign and therefore make an equation out of it. This equation, or any equation, can help us or can be used to evaluate an expression. That is, to find out what kind of values will be suitable for a particular pronumeral. Sometimes a term has a number in front of it. Sometimes it doesn't. Whether it does or doesn't, it has coefficients. When there's no number in front of a letter, we're assuming the coefficient of this letter is 1. If the coefficient is not 1, then there should be a number in front of it. Okay? So in this case, 7xy, the coefficient is 7. Here, it's minus 3y. Therefore, the coefficient should be minus 3. Sometimes a term does not have a pronumeral or variable, like this one, minus 2. And then this minus 2 is called a constant terms, which means the value, whatever these pronumerals will be, the value of this term is always the same, because it doesn't really have pronumerals to change its values. So it's just going to be constant. Right. Binomial expressions. Binomial is an expression with two terms, such as x plus 5 or x squared plus 3. So when we call something an expression, for example, a binomial, then we should only see one plus sign or one minus sign connecting two terms. Yes, if it is a three-term expression, it would be called trinomial, like x squared plus 2x plus 1. In Chapter 2, we actually have worked with binomials in expanding brackets. For example, this expression, a is multiplied by a binomial expression, that is, whatever that's in the bracket, x plus b. In that situation, we need to distribute a to x first, and then distribute a to b. And therefore, it becomes a times x plus a times b. So the middle sign here is carried on from here. Okay? And in the end, we have ax plus ab. The rule that we use to expand bracket and therefore remove it is called distributive law. Distributive law is used to expand and remove brackets. So a term that's outside of the bracket is multiplied by each term inside the bracket. That means that you have to be fair when you distribute. A term that's outside the bracket has to be multiplied to each of the term inside the bracket. If the number in front of the bracket is negative, then the sign of each of the terms inside the bracket will change when expanded. Now let's have a look. Here we have a multiplied by x, take away b. So how do we look at the signs? X has a positive sign, therefore we're not writing it, and b has a negative sign in front of it, So now we distribute a to x, then a to negative b. As a result, we have ax take away ab. If we have a negative sign in front of a, and we need to distribute the negative a to b as well as the c inside the bracket. You can see that initially this plus sign is carried on, but this negative sign is coming with a and evenly distributed to b and c. So as a result, you should have negative a take ab, take away negative ac. Okay, so when you have a negative number, a negative sign in front of the number outside the bracket, you have to distribute together it's not a anymore. It should be the negative a and then negative a to c. Okay. Binomials can also be multiplied together. For example, a plus b multiplied by c plus d. Okay. We can also use distributive law to expand them. The way that we do that is that we need to put a, so the first term in the first binomial, evenly distribute to each of the term in the second bracket. Okay, so a plus b, so a is distributed to c first, and then a is distributed to d, and therefore you have ac plus ad. Then you distribute the second term of the first binomial, that is b in this case, to each of the term in the following bracket. That would be multiplied by c plus b multiplied by d. Okay, so initially the immediate result of you expanding a binomial product should contain 4 terms, because you are first distributing the first binomial into 2 terms in the following bracket. That will give you 2 terms. And then you're distributing the second term in the first binomial into the 2 terms in the following bracket. That should also give you 2 terms. So initially, if you didn't do anything, the immediate result of you expanding a binomial product should be 4 terms. Alright, let's have a look. How do we expand these binomial expressions? We need to first use distributive law to expand them. And you can see that here you are given in some brackets, basically in all of the brackets, you also have constant terms with them. Okay, so it's likely that in the end you will have like terms, and you need to collect them before you leave it. Okay, so for the first question, you have x plus 3 multiplied by x plus 5. You're going to distribute x to both x and 5, and then distribute 3 to both x and 5. Okay, so that will give you x squared plus 5x plus 3x plus 15. You will notice that the middle 2 terms are like terms. They have the same prenumeral part. That's like terms. Okay, so we can add the numbers together and leave them as x squared plus 8x plus 15. For x minus 4 plus x plus 7, we have a minus in the first bracket. Remember, whenever we distribute, the negative sign has to come with a number. Okay, so it becomes x squared plus 7x. Then we're adding the minus 4 multiplied by x and the minus 4 multiplied by 7. So you need to make sure that you carry the negative in the multiplication when you distribute it. Okay? So as a result, when we calculate it and collect like terms, it becomes x squared plus 3x minus 28. Great. 2x minus 1 and x minus 6 multiplied together. Well, the first term, 2x, has a coefficient. Of course, it has to come with it. Also, at the same time, the negative sign and the negative sign has to go with the number. Okay? So we have 2x multiplied by x. Then why is here negative? Because the negative 6 makes this term negative. 2x multiplied by negative 6 is negative 12. And then you have a negative 1 distributed to x, and therefore you have a negative x. And then you have a negative 1 multiplied by negative 6. Therefore, you have a positive 6. Okay, so the sign, how do you decide for the sign? It's entirely coming down what's actually in the bracket. When you do the distribution, the signs, especially the negative signs, has to come with a number when you do the multiplication. Okay? And therefore, as a result, you collect like terms, that becomes 2x squared minus 13x. Okay? Minus 12x minus x, you're minusing twice. So you're basically minusing the two terms together. So therefore, it's 13x plus 6. Last one, 5x minus 2, 3x plus 7. Again, 5x, 3x, 15x squared. 5x, 7, 35x. This 7 is a positive, and therefore this positive here. Negative 2 times 3x, that's negative 6x. Negative 2 times 7, that's negative 14. So each of the term is a product of any of the two terms in the brackets multiplied together. Okay? And then when you collect like terms, it becomes 15x plus 29x, take away 14.